Okay, today we have our 5.3 lesson, which is on dividing polynomials. Up until now, we've talked about adding, subtracting, multiplying, and even taking polynomials to different powers. But today we're going to be talking about dividing polynomials. Now, a quick review on division. And anytime that you have a division problem like what we have here, what you're dividing by, or the bottom number, is known as your divisor. And the one that is on top, or the one that is being divided, is your dividend. So how we would write this is that our dividend divided by our divisor equals the quotient. So the quotient is the term for what you get in the end of a division problem. So those are just some things to remember about division problems. We will come back to those terms, so kind of keep those in the back of your mind. Now, when we're looking at these, our first topic is going to be on using long division. We'll get to that in a second because our first example is actually even more simple than using the long division process. In this one, because we are dividing a polynomial on top by a monomial on bottom, so the polynomial is our dividend, the monomial is our divisor, we can shorten our process up by a ton, actually. And so a concept to be thinking of here is looking back to our equations. If we had 2x equals 4y plus 8, and we wanted to solve for x, well, we would divide each side by 2. In the end, that would leave us with x equals 2y plus 4. So in this case, we had a larger divisor being divided by one term. But it broke down into two different terms, and how we did that was we separated them out. We had 4y divided by 2 plus 8 divided by 2, which in the end gave us our 2y plus 4. So anytime that you have a larger divisor or a larger dividend, and your divisor is just one term, as it is here, you can break it down into all the different parts of the divisor, of the dividend, each being over the divisor. So in this case, how that would look is we take our first part, that 5a squared b, and we just have that over our divisor, over the 5ab. Remember, anytime you have minus, that would be like adding the opposite. So we say that's a plus negative 15ab cubed over 5ab. And we go to our third part here, plus 10a cubed b to the fourth all over 5ab. So these are the three parts that we are working from. Now, to figure this out, we just simplify each one individually, and we can look at our first one and notice that 5 goes into 5 one time. So those ones divide out, leaving us just with 1. A goes into a squared and leaves us just with a. Now, how we can see that is a squared, again, being a times a over a. So we just take one out of each, and we know that we have just that a1 left. Or we can notice that we have a squared and a to the 1. And if we subtract 1 from each of these, a to the 1 down here becomes 1. And on top we have a to the 1, which is the same as a. And a over 1 would just be a. So in the end, we're left with just a on this one. Similarly to our 5s, b divided by b just is 1. So we are left with just 1 there. So our first term just comes down to a. Moving on to the second one, 5 going into negative 15, that's going to be negative 3. So our first part is negative 3. Again, a and a divide out. B to the first and b to the third leaves us with a b squared. So we have negative 3b squared is our second part. And our third part, 5 going into 10 makes 2. A into a cubed leaves us with a squared. let's write those ones down, 2 and a squared, and b into b to the fourth gives us b to the third. So here are our three parts. And again, we're not quite finished here. We have this plus a negative, which we can just rewrite as negative. So in the end, our final answer is going to be a minus 3b squared plus 2a squared b cubed. And each of these terms are different. We don't have any like terms, so we can't simplify it down. So this would be our final answer. Moving on, now we will go back and look at the division algorithm. Now back in our simpler days, we were only using numbers, just constants. So if we wanted to use the division algorithm to divide, let's say, 3,265 by 5, we put our divisor, the 5, on the outside, and 3,265, the dividend, goes on the inside. We would say then that 5 goes into 3 0 times, but 5 goes into 32 6 times. So we put the 6 above the 2 because 5 goes into 32 6 times. Then we take 6 times 5 to get 30. 32 minus 30 becomes 6. Or 2, sorry. Then we have to drop down the 6, and that leaves us with 26. 5 goes into 26 5 times. 5 times 5 is 25. And 26 minus 25 leaves us with 1. And we still have to drop down this 5. So 5 goes into 15 3 times. 3 times 5 is 15. 15 minus 15 is 0, which is good because that implies then that there's no remainder. So 3,265 divided by 5, the answer is 653. So remember, that's how the division algorithm works. How can we apply that to our polynomials, though? We just have to make sure that we're writing things in the same exact form. So again, we have our dividend and our divisor. We put our divisor on the outside, our dividend on the inside, and then just apply how each of them works. So again, we always looked at the first one first, and we said that we're looking at how x would go into x squared. Now each of these has just a coefficient of 1, so we know that there's not going to be any coefficient value, but to go from x into x squared, we would need to times by x. So when we take x times x, that gives us x squared, and x times negative 5 gives us a negative 5x. Now again, like before, we wanted to subtract this. When we subtract this, our first one becomes negative. When we're subtracting a negative 5, that becomes positive. So make sure to write that as positive 5x now. Now when we solve this through, negative 2x plus 5x becomes 3x. X squared minus x squared just becomes 0. So now we are just left with 3x. Now we are looking at how x goes into 3x. So x going into 3x, that one is going to have a coefficient value. So that's going to be positive 3. 3 times x gives us that 3x. 3 times negative 5 is negative 15. We drop this negative 15 down. And you can do this earlier, before. It's just that you only needed to look at the 3x before when dealing with how the x minus 5 goes into it. Now that we get to this point, again, we have to subtract this. So we have our 3x becomes negative. This 15 becomes positive. So now, when we solve, our negative 15 plus 15 becomes 0. Our 3x minus 3x becomes 0, which means there is no remainder. And our answer is just x plus 3. So the polynomial x squared minus 2x minus 15 divided by x minus 5 gives us the answer of x plus 3. Now when we want to use long division to divide again, we need to remember just to set it up correctly. We put our divisor on the outside with our dividend on the inside. And we're just looking at how our x goes into our x squared. That would be x times. X times x is x squared. x times negative 4, negative 4x. Now when we subtract it, this one becomes negative, this one becomes positive. 2x plus 4x becomes 6x. X squared minus x squared is just 0. This time I'm just going to drop down the 24 now, so we don't forget to later. Again, you don't have to do it now, you can do it later. It will come up though. X going into 6x is just 6. Be 6 times. So 6 times x is just 6x. 6 times negative 4 is negative 24. Now from here again, remember we're subtracting it. So this one becomes negative, this one becomes positive. 24 minus 24 is 0. 6x minus 6x is 0. So again, there's no remainder. Our final answer is just x plus 6.